Hey, 11th graders. I wanted to welcome you to a new week. I think this is crazy. I think this is our seventh week of doing this. And I know it's getting to be a lot. I know that it's starting to feel unending. I know that it's starting to feel like the new normal, whether we want it to be or not. And I know that a lot of you felt very dejected after last week, after learning that your spring break was not happening anymore and instead being divvied up as 3-day weekends pretty much till the end of the school year. There's some pros with that, and there's definitely some cons with that. And I want to let you know that us teachers really debated it, and us teachers really were divided pretty evenly about the whole thing. And I know it's hard, and I know that all of this is really hard. And I want to just take a second to thank you for what you are doing, and I want to take a second to thank you for still taking your education seriously in this time. I have noticed a sharp decline, as you guys can probably see, some of you can see in your gradebook, a sharp decline in materials being turned in. A lot of you are not turning in your homework at all, and some of you are now not even turning in quizzes. And that's really concerning to me. And I don't know if it's because we had like a week of me not like babysitting and like checking in and saying, hey, are you with us? Hey, are you doing this? And I don't know if that helps you for me to be that person to say like, hey, you're in math class right now and like come join us and come participate. Or if you like being on your own devices with this. I need your help. I need your help to tell me what to do because I'm kind of at a loss in terms of how to. Some of you are working super hard. Some of you are maybe tapering off a little bit, but still turning stuff in. And I want to let you know that like I see it and I appreciate it. And this is definitely not everybody, but even people who are feeling like they're on top of it and turning things in, even if you have some idea of how I can help because you can observe what's going on with your peers, if you are one of the people who's struggling on turning things in, please just shoot me an email. It doesn't have to be professional. You don't have to like call me by my name or like make it sound professional. Just shoot me an email and say like, hey, this sucks. I don't like that. Or, hey, I really appreciate it when we do these things together. Or I like it when you reach out. I like it when we do the Desmos. I don't like it when we have Kahoot. I don't know, any of those things. Good and bad, I want all of it because I do care about you and I care about your education and I care about what you're getting out of this time. And I want to make sure that you do too. And so please, please, please help me out and let me know what I can do because I want to help. Okay, with that, we're finishing our notes today on 5-3. 5-4, Yana reached out to me and asked me when the test was happening. Our next test was happening. 5-4 is our last lesson of notes. Like all of our other lessons, it's going to take 2 days for us to complete. And then we're going to have about a week of review where I'll have like different review activities for us to do. So I believe April 28th is when your test is tentatively scheduled. So just putting that on your calendar and on your horizon, I would recommend writing it down if you have like a daily calendar that you're keeping track of. Okay, so last class what we learned about was the law of sines. And remember that the law of sines, or the sine rule, it's all for non-right triangles, hence why we're talking about a unit called non-right angled trigonometry. And it's talking about the relationship of side lengths and its opposite, of angles and its opposite side lengths. Sorry, my Hangouts is blowing up. So I want to talk to you about the cosine rule, which is also for non-right triangles. Okay, so the cosine rule is for non-right triangles. Sorry. Okay. So I'm going to draw a triangle that looks to be a non-right triangle. Remember that our vertices are all uppercase letters. So I'm going to label uppercase A, B, C, and then side lengths are always going to be lowercase letters, and they are the opposite side length of the angle which has that letter. So opposite of big A is going to be small a. Opposite of big B is going to be small b. Opposite of big C is going to be small c. The cosine rule is crazy. It looks like this. C squared is equal to a squared plus b squared minus 2ab cosine of uppercase C. So that is our law of cosines. I'm fairly certain it's in your formula packet. What all of these variables mean, it does not necessarily have to be side length A or side length B. It's the relationship that's indicated there. We're trying to solve for C. Notice that C is on the outside of the equal sign. We're not always solving for C, but we put C on the other side of the equal sign because we have the angle uppercase C. If that is the angle that we have, then we're going to put its opposite side length in this spot in our equation. Now we also have A, lowercase a, and lowercase b. Those are pieces that we're using in order to plug into our law of cosines or our cosine rule in order to solve. Now, sometimes we might have lowercase c and lowercase b, and we might be trying to solve for a. Those are a little bit trickier versions of this formula. What I would focus on is the angle that you do have. If you're trying to set up relationships, focus first on the bit uppercase c. What angle do you have? And then plug in its opposite side length, whether you have it or not, on the outside of the equal sign, and then take your other two side lengths. It doesn't matter which one's A and which one's B, doesn't matter at all, but plug in one for A and one for B, and that's what we do. So let's go through and do an example. Let's do a couple examples. So notice here that we have an angle and then two side lengths, one on either side of that angle. So I'm going to say that this is my C value. Like with a lot of things, I would recommend writing down your formula first. Oh, a squared plus b squared minus 2ab cosine of C. You can label your variables. C is really x. A, well, let's let A be 4, and let's let B be 5. And then uppercase C is 30. So we have now all of our puzzle pieces, all of our ingredients that go into the recipe that is the formula. So we put it all together, and we are going to get that x squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 30. You can plug in that entire right-hand side of the equation into your calculator, just exactly as you see it. You can do 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 30. And we get that x squared is equal to 6.36. I rounded it to 3 significant figures. Realize that we're not going to use this rounded number. We're going to use our exact value to take the square root. $2.52 as our value for x. I want you to take a second, take a step back and say, does that make sense in the world of these numbers? In the world of these numbers, we had side lengths 4 and 5, and 2 seems to be about within that range. It also makes sense that 2 is smaller than 4 and 5, and you can see from this diagram that they're implying that that 30-degree angle is the smallest of all the three angles. The smaller your angle gets, the smaller the opposite side gets, right? So the larger your angle gets, its opposite side gets larger. So if you're talking about the smallest angle of the triangle, your opposite side length should be the smallest of the 3 side lengths. So this type of reasoning is good reasoning when we're talking about explaining your reasoning on the IB exam or on an IA, and I'm like, hey, I need you to reflect upon the process, taking a second and saying like, 2.52 makes sense because it's within the world of 4 and 5. It's also opposite of the angle that is the smallest angle in the triangle, which means it should be smaller than the other 2 sides. That's also a great way to just double check your work. But we are in IB looking for reasoning skills, and things like that we talk about in class are good reasoning skills to be able to have just ready to go. Okay, so looking at this problem and seeing 150 degrees, and it's definitely implied in this diagram that this angle is the largest by far of the opposite side lengths. So I'm going to make a hypothesis here and say that x is going to be larger than 6, definitely larger than the square root of 17. We have the angle C.